In other words, by how much did the temperature change because heat flowed from the, and that's how you find enthalpy change using calorimeter data. This is a little calorimeter. Let's say we did a reaction inside a calorimeter, which is just some water, and let's say that that reaction produced heat. Well, the heat that the reaction produced would be also equal and opposite to the heat that the water absorbed. And so I can't exactly measure heat flowing, but I can measure a temperature increase. So let's say the temperature initial, when the reaction occurred, went up. This would be a temperature change. I can measure that, and that temperature change would depend on the amount of water I had. So let me introduce this equation. Q stands for heat, and then the W is just for water. Heat is typically in joules, maybe calories. The mass of the water would be in grams. That's how much goes into the calorimeter. And then this term is called specific heat capacity. And those are known values. They are in tables in your textbook or online. And then delta T is T final minus T initial. In other words, by how much did the temperature change because heat flowed from that reaction. So once we're done with that, we'll take that heat of reaction, or the heat that flowed in this reaction, divide by the number of moles that we used to produce that heat. So let's look at this example here. I've got all the parts ready to go. I see I've got the mass of water, so I've got 120 grams of water in my calorimeter, and the temperature is going to go from 18 to 22.5. So heat is going to be flowing from the reaction into the water. This is exothermic. You know that term, exothermic. And I can measure that temperature change. All right, let's go ahead and find the heat that the water absorbed, and that would be equal to 120 grams. The specific heat of water is given. It's got a bunch of units. It's joules per gram degrees C. The temperature change is 22.5 minus 18. Okay, and then when we multiply, look at the units here. Grams cancel, degrees C cancel, and I'm left with joules. And so the heat of the water is 2257 joules. Okay, now I know I've got too many sig figs. I'll hang on to them until the end. So the water absorbed that, and so the reaction produced that. So I'm going to give it a negative sign here, right? Equal and opposite. This is exothermic. So the enthalpy change for the reaction is the heat that it produced in joules divided by how many moles did we use to get this, right? The scale of the reaction. So divided by 4.5 moles, and we get negative, now I'll fix my sig figs, basically 500 joules per mole. Don't forget your mole in there. And that's how you find enthalpy change using calorimeter data.